Okay, welcome to part 2 of this video on mean, median, mode, range, outliers and problem solving. In part 1 we looked at mean and median, and now in part 2 we will concentrate on mode, range, outliers and problem solving. So let's get started. Okay, so the mode. Mode is the most popular piece of data, the value that occurs the most. So the number that is in the data set the most. As it says here, example, 10 students took a French test. Here are the results out of 100. 56, 67, 56, 72, 73, 93, 45, 82, 80 and 75. So which one appears the most? So sometimes it's nice just to order it just to make sure. So let's have a look, just order it together. So I think they start at, so 45, I think that's the lowest number. You don't have to order it, but just make sure that it's a little bit clearer for you. You're definitely getting the right mode here, and there's not 2 modes, or there's no 0 modes. So sometimes ordering it just makes it a little bit clearer. Next one is 56 and 56. Just like the part 1 video, just score them out when you've used them, just makes life a little bit easier. Next one, 67, and then 72, and 73, and then 75, 80, 82, 80 years, 82 years, and 93. So which one occurs the most? All right. So it seems with most of the values in this data set, there's only one of them, but you can see that with your 56, there's 2 of them. So the mode in this data set, the most popular piece of data, is 56. Let's move on. Again, like part 1, guys, if you want to try it yourself, because I'm going to go over these questions, just pause the video. So again, not very many values in this data set, so it's very easy to see the mode. There's 2 values of 5, so the mode in this case is 5. Okay, let's move on. This one again, there's only 4 members or 4 values in this data set. Again, very easy to see that the number 12 appears the most often. So the mode in this data set is 12. Next. The mode in this one, so I've only got 1, 1, 1, 4, 1, 6, and 1, 9. So none of the values and none of the members repeat themselves. So in this case, there is no mode. Okay. Let's move on. Okay, in a nursery, 10 children's ages were recorded. The results are shown below. What is the modal age? So modal is another way they can ask you. There's another kind of term for it. They're really just asking you the mode. Which one is the most? Which number appears the most often? Again, when you look at that, like there's quite a lot of zeros, quite a lot of ones, quite a lot of twos. Again, it might be nice just to order it, just to make it really clear in your head. So 0, 0, 0. I can see there's 1, 2, 3 zeros. Good. 1, 2, 3, 4. It looks like 4 ones. 2, 3, 4. And it is 2 twos. Okay, so which one is the modal age? So it looks like the age 1 appears the most. So the modal age is 1. Okay, perfect. Let's move on. Range. Let's go on to the range. So the range is not an average, it's a measure of spread. This means the range is a way of telling us how spread out the data is, how varied a data set is. So the range is the difference between the highest and the lowest data value. So how varied it is, that's a nice word, that word there, the varied word. or the spread. Okay. Again, if you wanted to order it, you could just make life easier, or you can just look through the data set depending on how many values there are. In this case, the biggest number is 16, and the smallest number is 4. It's quite easy to make a wee mistake here. So again, if you wanted to order it, just to really double check that you haven't missed out the highest value and the lowest value, then you can. Okay, so the range equals 16, take away 4. So the range is 12. Good, let's move on. What is the range here? The biggest value, the biggest member, 27. And the smallest value is 8. So the range is going to equal 27, take away 8, which is 19. Again, remember guys, just to pause it if you want to do it first before I go over it. The range in this case, the highest value, 25, the lowest value, 6. So it's going to be 25, take away 6, which is 19. This one here, highest value, 17, lowest value is in fact -3. So the range, 17, take away -3. I don't really want to get into negative numbers at this point, but you're just telling me how far apart they are. So if you're on -3, what do I have to do to get to 0? Just think of a number line here. This here is -3. Oops. This here is -3, sorry. This here is 0 perhaps. And the end number here is 17. What do I need to do to get to 17? So I'm at -3. If I jump from -3 to 0, I'm adding on 3. If I jump from 0 to 17, I'm adding on 17. So what is 3 add 17? 3 add 17 is in fact 20. So your answer is 20. Okay, let's move on. Okay, says here, Steve asked 14 friends how many siblings they had. The results are shown below. So we've got 1, 1, 2, 2, 2, 3, 1, 2, 4, 1, 2, 1, 3. I have got one hidden here, and I would like you to take a wee guess as what you think it would be. Okay, so the number underneath here that I have hidden. So let's order these while you think about that. What's under that box there? So we've got a 1, 1, 2, 5 ones. 1, 2, 3, 4, 5. We've got 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5. We've got a 3 and a 3, so 2 3s. And we've got a 4. Okay. So what do you think the answer is in there? So the mode, the most common data, you actually have really 2 modes here because you have got 5 1s and you have got 5 2s. So they seem to be the most popular amount of siblings when asked. So if you had to make an educated guess, you would maybe think it was the answer 1 or number 2 underneath that box. So let's reveal it now. Ah, 17. Didn't expect that, did you? Now, is that possible? Yes, it is. I actually know someone many years ago who had 18 children. So it is very possible, but it doesn't really fit in with the rest of the data. It's a value that you weren't expecting. I would say you were probably expecting the number to be 1 or 2, but here we are having the number 17. Let me just slide this down. So it says here 17 siblings has distorted the data. This result does not fit in with the general pattern. It was not expected. So you did not expect me to reveal 17 here. Okay, let me just scroll down a wee bit more. Oops, sorry. There we go. So an outlier is a value that does not fit in with the other pieces of data. It's an exceptional value. So very, very different from the other pieces of data. And this outlier is something we will discover a little bit further on in our journey, but it's something I just wanted you to be aware of at the moment. If you were to work out the range, for example, what we've just done there, with the 17 in your data set, what would the answer be? So your range with the 17 in your data set, biggest number would be 17, smallest number would be 1, so the range in this data set would be 16. But if that 17 wasn't there, the range would be the biggest number being 4, the highest value, and the lowest value being 1, and the answer is 3. So it really does distort some of the statistics that comes out of it when you have an outlier. But again, it's something we will go into in a bit more detail further on in our journey of statistics. Okay, let's move on to something I kind of wanted just to be aware of. Okay, we're going to some problem solving now. So again, I just want to go back and just kind of look at some of these things we've done before in algebra. I don't really want to bring letters in at the moment. I know a lot of these have done algebra, but I just want to think of the unknown. So this here, this little box here, is an unknown value. So if I was to say to you something plus 3, so something plus 3 is equal to 10. Okay, so I'm looking at here. By inspection, you would be able to figure that out, I'm sure. So you would know that the answer is 7. However, let's think of a method to solve that, because you need methods in maths quite often when things get a bit more complicated. So that unknown value, there is a 3 being added to it. So this 3 has been added to it. How do I undo add 3? So the opposite of adding 3, how do you undo that? Would be taking 3 away. Okay, so to find that answer more using a kind of method, you'd be saying to yourself, if I took 3 away from both sides, I would be left with this unknown value. If I took 3 away from here, I wouldn't be left with anything, equals 10 take out 3 is 7. And you already knew that by inspection. Again, I want you to consider the next one, and there's a reason why I'm looking at this, just to kind of go on to the next problem solving question we look at. So again, you've got something plus 3 all divided by 2 equals 10. Okay? So again, how do you undo what's happened to that unknown value? So the unknown value plus 3, and then it's been divided by 2. Now I said divide by 2 last, so that would be the first thing I would want to undo. So how do you undo divide by 2? You would multiply by 2. So I'm just going to put a wee method line here. I'm just going to write multiply by 2. I have to multiply the left-hand side by 2, and I have to multiply the right-hand side by 2. If I multiply this left-hand side by 2, it's already been divided by 2 as well. So if I multiply by 2 and I divide by 2, they in effect cancel each other out. So what would happen is you would just have your unknown box, your unknown value, oops, plus 3 equals, remember what you do to the left hand side, you must do to the right hand side. So we've got 10 multiplied by 2, which is 20. Okay? And then it just becomes the same problem we had at the beginning. So again, we've got an unknown value plus 3 equals 20. How do you undo plus 3? Subtract 3 or take 3 away. So we write a working line here. So we're left with your unknown value equals 20. Take away 3, which is in fact 17. So it's something I just want you to consider as we go along, because looking at the next problems. Right, so we're going back to looking at the mean, which we did in part 1. So two numbers have a mean of 12. So one of the numbers is 9 and the other number you do not know. So this is kind of the reverse of mean. You usually are given the data set and you're asked to work out the mean. So in this one, I've got a data set, but I only know one of the values. I don't know the other one, but I know the mean. Now, if you were to work out the mean, remember, if you were to try it yourself, just pause the video. What would you do if you knew all the members? So you would do the mean equals 2 plus this unknown, so we'll get box just now, divided by, now how many members or how many values in this data set? Not very many, there's 1, there's 2. So you would divide it by 2 and your answer would be, in this case I've told you the answer is, I've told you the mean is 12, so it would be equal to 12. So thinking about what we did in the last slide, how would you undo that? How would you undo this divide by 2? You are going to times by 2. So let's go put a wee working line. And we'll times both sides by 2. So again, on the left hand side, if I times it by 2 and there's already a divide by 2 there, I'm just left with the top part, numerator. So I'm left with 9 plus something equals, and I also have times that 12 by 2. 12 times 2 is 24. So then I've got a number that I don't know, plus 9 is equal to 24. How do you undo plus 9? You take 9 away from both sides, but take it away from the left hand side. We're just left with this unknown value, and take 9 away from your 24, and you're left with 15. Okay, and you can double check it again. So if that answer was 15, let's double check. Yes, it is. It was 15. So if you were given that initially and asked to work out the mean, does it work? Of course it does, but let's just double check. So you do 9 plus 15 divided by 2, because there's 2 values or 2 members. 15 plus 9 is 24. Oops. Sorry, I think that froze there a little minute. 24 divided by 2, which is 12, which is your answer, mean of 12. Okay, a few more slides very similar to that. So again, please pause it so you can do it yourself. So two numbers have a mean of 42, 70 plus something unknown. So the mean's 42. What is that unknown value? So again, you've got your mean equals your 70 plus your unknown value divided by 2, because there's 2 members, 2 values in this data set, and your answer is equal to 42. How do you undo that? How do you undo divide by 2 and times by 2? So it becomes 70 plus your unknown value equals 42 times 2, which is 84. Then you've got your unknown value plus 70 equals 84. And again, you can do that by inspection. But if you want to do it kind of like the solving equations method, just to get into that way, you're going to undo, add 70 by subtracting 70, and that unknown value is going to be 84, take away 70, which is 14. Let's double check. Perfect, you're correct. Let's move on. Got a few more like this to do. Two numbers have a mean of 5.5. You've got the number 8, and again, an unknown you don't know. So we've got the mean equals 8 plus something divided by 2, because there's 2 members or 2 values in the data set, equals 5.5. When you undo that divide by 2 by times and by 2, so we've got 8 plus your unknown value equals what's 5.5 times 2 does 11. Unknown value plus 8 equals 11. How do you undo plus 8? Subtract or take away 8. The undo unknown value is equal to 3. Again, let's double check. Perfect. Next. 3 numbers this time have a mean of 15. So it's 7 plus something plus 18 divided by, what would you divide by? Yes, you would divide by 3 because there's now 3 values of 3 members in this data set. So we've got mean equals 7 plus something plus 18 divided by 3 equals 15. And we're going to undo the divide by 3. We can do times by 3. Good. So you've got 7 plus unknown plus 18 equals 45. Before you times by 3, it might have been nice to add the 7 and the 18 together. I'm going to do that now. So what is 18 add 7? So we've got your unknown value plus 25 equals 45. How do you undo that plus 25? We take 25 away. Do your unknown value equals 20. So unknown value should equals 20, and it does. Good. Clear? Okay. Right, here we go. Here's a kind of wordy question that we're going to go through together. So here are the weights in kilograms of a group of 7 wolves. So there we go, in kilograms, 7 weights are there. Find the mean, the mode, the median, and the range. We're going to flick to the next page to give us a little bit more room. Okay. So we've got mean equals, remember what to do, you're going to add them all together and divide by how many values or members are in the data set. In this case, it tells you there's 7, and you want to double check by counting them, you can. Okay, I'm going to add all of that together, and you should get 385 divided by 7, and the answer is 55 kilograms. You want to find the mode, median, and range, so it might be a nice idea just to order everything so it's in the right order. So what one comes first? Looks like 47. And then look at 50s, looks like 52 next. And then 55 and 55. And then 57, 59, and 60. Once you've ordered them, remember I said in part 1, just double check that you have 7 values, 7 members there. So 1, 2, 3, 4, 5, 6, 7. Very, very easy to miss one out, so just double check. So good, it's all ordered for us. So the mode, remember what the mode is, the most common number in the data set, and in this case, it is 55. 55 appears twice. Every other value or member only appears once. So 55. The median, remember that's the middle value. So there is 7 members or 7 values in our data set. So remember, you're only, because it's an odd number, you're going to be circling one number in the middle. So it looks to me like that is the median. Double check. So is it the same amount of members or values on this side? Yep, there's 3 values and members on the right hand side and 3 values or members on the left hand side. So 55 is indeed the median. We should have put kilograms for both of them as well, sorry. Okay, and the range, remember, is the biggest value, which is 60. The highest value and the lowest value is 47. So you're going to do 60, take away 47, which is 13 kilograms. Okay, so that's us. So let's look at the next part. Next part is quick problem solving. So let's have a look. Sorry, I'll clear that. Okay, so it says, suppose two more rows were added. Two more rows were added to the data set. I think it's meant to be say, sorry, the typo here. So there are now 9 wolves. The mean weight of the 9 wolves is 54 kilograms. How much do the 2 wolves weigh together? And then it goes on to kind of second part. So let's look at this part together. I'll just move this up so I've got a wee bit more space. Okay, a bit more space to write. There we go. So the problem solving slides that we looked at before this question is going to help us with this question. So suppose 2 more rows were added to the data set. So excuse this typo here. Just ignore this. Whereas the data sets are now 9 rows, the mean weight of the rows is now 54. So what you're going to do is you're going to do your 52 plus your 57 plus your 55 plus your 60 plus your 59 plus your 55. There is an easy way, but I just want to show you really clearly what you're doing. Plus wolf number 1 added and wolf number 2 added. Okay, so if you're finding the mean, you're no longer dividing by 7 because there's no longer 7 members of the group. There's been 2 more wolves added, remember. So you're dividing by 9. And the mean weight was 54. Okay, so let's simplify that slightly. In the slide before, we already added all of these values together. I'm just going to flick back to the last slide to see what that answer was. We don't want to do any extra work and we don't have to do. So if I flick back, oh, I think I've deleted it, haven't I? Let me have a look. I think it was 385, wasn't it? Okay. There we go. Yep. Okay, 385. So we've got 385 plus your first new wolf and your second new wolf divided by 9 equals 54. How are you going to get rid of that divide by 9? You are going to times by 9. So we'll get 385 plus the first new wolf, add the second new wolf, and you're going to times 54 by 9, which is 486. You now want to get rid of this 385. You're adding that 385, so to undo that, you are going to subtract or take away. Okay, so you've got wolf number 1, wolf number 2, 486 take away 385 is 101. And that's what it asks you for. It says, how much do the 2 new wolves weigh altogether? You don't know what each of the wolves weigh at the moment. You don't have enough information at this point. So you know altogether the 2 wolves weigh 101 kilograms. So that could mean that one of them, so 101, could mean that one of them is 50 kilograms, which means the other one's 51, or it could mean one of them's 45 kilograms, which means the other one is 56, and so on. There could be numerous answers there, as long as they add together to get 101, and it makes sense with all the other data in the data set. Okay. Now, so remember that 101, okay, so the two wolves together add up to 101, because I'm going to clear this just to go down to the next part of the question. Okay, here we go. Okay, so I'll just write up here. Two wolves together, so there was 101. Okay, so it says here now the range of all 9 wolves is now 14. Okay, is it now possible to find the exact weight of each of the 2 new wolves? So the old range was 13 kilograms. The new range is now 14 kilograms. So that means at least one of the new wolves must have the new highest or biggest weight, or they must have the new lightest. It have to be the new heaviest, is probably a better word. One of them now has to be the heaviest wolf, or one of them now has to be the lightest wolf. And see if I just flick back and click on this just to get. Okay. Just going to paste in there. So that was the original 7 wolves. So when I look at the original 7 wolves, the heaviest one at the moment before the other 2 were added. So remember, we've got this data, and you've got another 2 added. I'm going to put it down here. Another 2 added. These 2 together make an answer of 101. So the heaviest one prior to the 2 new wolves being added was 60. Okay, and you know that the new range is now 14. So if I did 60, take away something, gives me a range of 14 kilograms. What must that something be? So 60 take away what would give you an answer of 14? And the answer would be 46. Is 46 already in the original data? No. So that means one of the wolves must weigh 46. Now, if one of them weighs 46, remember, both of them together weigh 101. So if one of them weighs 46, then the other one must weigh 55. So you were given another piece of information to work that out. I have considered the other option of looking at the lightest original wolf and seeing if the new wolves that were added in could be the heaviest one, but it didn't actually work out. So that is your answer. Okay. Now that is tricky. It's very problem solving, but I hope the problem solving questions we did on the lead up to this helped us with it. Right, I'll clear this. We're just about to finish off, guys. This is a wee question I'm not going to give you the answer to. I want you to try it on your own, work it out, and you can give me a wee comment and give me the answer below if you work it out. And anyway, that's us now finished, and thank you very much for watching. Okay, take care. Bye now.